Hello, everyone. Welcome to the semester's technical development track. My name is Jyoti, and I am the director of IT for AIS this year. And we will be learning about what logistic regression is and how to do it. So, here is a quick table of contents in case you need to come back and look at this PowerPoint. I will be adding this PowerPoint to the website for you to go back and look at it whenever you need. So there are three main types of machine learning. On the left, we have unsupervised machine learning, where the model works with unlabeled data and tries to find patterns or groupings on its own. And then in the middle, we see supervised learning, where the data is labeled and the model learns from input-output pairs. This is the type we will be focusing on because logistic regression is a supervised learning algorithm. And then finally on the right, we have reinforcement learning, where an agent learns by interacting with its environment and receiving rewards or penalties based on its actions. So for this presentation, I will be using a breast cancer dataset where you can see if a tumor is malignant or benign, and since we know these labels, we'll be using supervised learning, specifically logistic regression. Logistic regression is a machine learning algorithm that we use when the outcome we want is a binary result, like yes or no, malignant or benign. It's similar to linear regression, but linear regression predicts a continuous number, while logistic regression predicts a probability between 0 and 1. It does this by taking the input features and passing them through an S-shaped curve called the sigmoid function, which squeezes the values into that 0 to 1 range. Finally, we apply a threshold. Usually, if the probability is greater than or equal to 0.5, we predict yes, and if it's less than 0.5, we predict no. So in our project, this means the model will output the probability that a tumor is malignant, and based on that threshold, we classify it as malignant or benign. In this slide, I've included these two graphs so you can visually see the difference between linear regression and logistic regression. On the left, with linear regression, the model tries to fit a straight line through the data, but the problem is that predictions can go below 0 or above 0, which doesn't make sense for probabilities. And then on the right, you can see the sigmoid function, the S-curve that logistic regression uses, and this curve squashes all predictions so that they stay within that range of 0 and 1, and that's why logistic regression is much better for binary outcomes. So when picking a dataset for logistic regression, there are a few things that we look for. First, the target variable should be categorical and binary. So it should either be something like yes or no or 0 and 1. Second, the predictors can be either numerical or categorical, but they need to be in a form the model can use. And I will later go more in depth about what your target and predictor variables are, but for now, this is just a little bit of background information. Third, each row should represent an independent case, like one patient, one email, or one transaction. And finally, the dataset should have a decent number of rows and not be heavily imbalanced between the classes. The first step for this project would be to set up our working environment, and we can start by creating a folder specifically for this project and adding our chosen dataset to it. So in my case, I downloaded the breast cancer dataset from Kaggle and saved it in a folder where I can easily access it. And I attached a document with a couple of datasets that you can choose from specifically for this project. Then we open Jupyter Notebook and create a new file. This new file will be the main place where we write all of our code and run our analysis. At the end of the PowerPoint, I will include a walkthrough, so don't worry if you can't keep up right now. Before we start working with our dataset, we need to import some Python libraries. So first we have NumPy, which is mainly used for working with arrays and performing mathematical operations. It's way faster than using regular Python lists, which is why we use it. Next, we have Pandas, which is one of the most important libraries for data science. It lets us load, clean, explore, and manipulate datasets easily. Finally, we will use scikit-learn, which is a library for machine learning. It provides tools for predictive data analysis, and in this project, we will be using it for classification with logistic regression. We will also be using Seaborn, which is a visualization library that helps us create graphs and better understand our data. So here are some common pandas methods and attributes you've probably seen before, but I've added them here as a quick refresher in case you're unsure about what they do when we use them later on. You can always come back to this and look at it. Once we have our data set, the first thing we want to do is read it into Python using pandas. So here I use .read_CSV to load the breast cancer data set. After loading the data, we can use .head to quickly look at the first 5 rows. This gives us a preview of what our data set looks like, including the columns and some sample values. It's also important to check for any null values because we will be removing those later because they can affect our analysis. So just make a note of it, and in the next steps we will be removing it. So this step is all about just getting familiar with your data before we start cleaning and preparing it. After loading our data, the next step is to check for null values or missing data. Missing values can cause problems during training, so it's important that we identify them early on. So here I use 2 different methods, a heat map on the left to visualize any missing values, and finding the sum of all the missing value or all the null values on the right. And as we can see, every column has 0 null values, which means that the dataset is already very clean. After we check for null values, the next step would be to clean up any unnecessary columns or any of the null values that we find. In this case, the ID column is unnecessary because it doesn't provide us any useful information for predicting whether a tumor is malignant or benign. It's just a unique identifier for each record, so keeping it in the data set wouldn't add value to our model. So we can drop the ID column, leaving us with only the meaningful information that can help us in classification. And if you did have any columns with missing values, this is when you would be removing them. Machine learning models can't work directly with text labels, so we need to convert them into numerical values. In our dataset, the diagnosis column originally used M for malignant and B for benign. To make this usable for logistic regression, we encoded it into numbers, so malignant is 1 and benign is 0. This step is also called label encoding, and it allows the model to recognize the diagnosis as a binary target variable. So instead of text, the model sees clear numerical values that it can use for prediction. After encoding the target variable into 0s and 1s, the next step is to make sure the data was encoded correctly and to check if it's balanced. So here I used value counts to count the number of benign cases, which are labeled as 0, and the number of malignant cases labeled as 1. The bar chart shows that we have more benign cases than malignant ones, but both classes still have a decent number of samples. This is important because if the data were heavily imbalanced, the model might become biased towards the majority class. In our case, the dataset is not perfectly balanced, but it's good enough for logistic regression. The last step for this lesson is checking the data types of our dataset. For logistic regression, all of our values need to be numerical because the model works with numbers, not text. So using .info, we can see that the features are stored as float, which are decimal numbers, and int, which are whole numbers. So this tells us that our data set is clean, fully numerical, and ready for the next step, where we will be splitting it into predictors and the target variable for modeling. So next lesson, we will be splitting our data into the target and predictor variables, normalizing our data, and training our model. Okay, so we're gonna open up Anaconda, and if you don't already have it downloaded, you can go on their website and download it for free, and it doesn't take long to download at all either. And then once you open it up, you're just gonna launch Jupyter Notebook right here, and then find the folder that you put your data set in. So I just created a separate folder, put my data set in there, and then you can press on new, press Python, and then this will create a new notebook for you to write all your code in. So the first step for this would be to import pandas and import Seaborn. And then after we do that, we want to load our data in, so we're gonna do this. I made a typo. Alright. So we want to have a quick look at what all of our columns look like. So we can use dot head to see the first 5 rows, and we can see that we have the ID, the diagnosis, and then all of these other columns. And if there are any null values, you should be able to see them throughout the data set right now, but I don't see anything. So what I'm going to do is make a heat map to see a heat map of all the null values to see if there are any. And this shows me that there are actually 0, but if I'm still unsure, I can check again. And then again, this just shows all the column names and the number of null values in each column. So again, this says all 0s, which is a good sign. So after doing all these steps, if there were any values, any null values, you would want to remove them, and you can do that by using dot drop. We can put in the column name and then make axis equal 1, and that will make sure that we're dropping the column instead of a row. If we were to put 0, that would be dropping a row, but we want to drop the column. And then make in place equal true, and that will just make sure that we're just updating our current data frame instead of creating a new one. And then we can check that it worked just by using dot head again. And then as you can see, the ID column is now gone and everything looks good for us to keep going. So the dataset that I'm using doesn't have any missing values, but depending on which dataset you use, there might be columns that do have missing values, and depending on how many missing values there are compared to how many rows there are in total, there's like a couple ways that you can go about it. So let's say that this has like 1,000 rows and radius mean has like 800 missing values. In that case, since there's not a lot of information that we can work with, you would just want to drop that column similar to how we dropped this ID column. But say that radius mean had only 100 missing values. In that case, what we can do is, or we can fill in the gaps by finding the median. And we would do that by doing data and then putting the column name so that we can select the radius mean column, and then we will do fill and A, which will replace all of the missing values. And then in that we can select the column again. And then do dot median. And then do in place equals true so that we can change the data set itself or the data frame itself. So this is a good option for when you have like a good amount of missing data, but you still want to be able to use that column. But say that radius mean only had 2 missing values. Instead of finding the median, we can just find the most common values and fill it in that way. So we would do the same thing, select the column, and then replace the null values. And then dot mode, and then we can also put 0, which will make sure that we get the first most common value in case there are ties between the most common values. And then again, in place equals true. Depending on your data set, these are a couple ways that you can just fill in the gaps in your data, and then after you do this, you can use data.isNull.sum to make sure that there are no null values left in your data frame. So now we want to do the encoding and turn all the M's and B's into 0s and 1s. So we're going to do data.diagnosis so that we can we're only focusing on the diagnosis column. And then we're going to do an if-else statement. So one if value equals M, else 0 for value in data.diagnosis. And then again, we can check if it worked by doing data.head. So as you can see, all the M's have turned into 1s. And we can't see if the B's have turned into 0s, but we can check this by making a bar chart. So to do that, we can do data and use value counts to count the values of each kind, and then plot. And then there we can see that there are only 2 values, 0 and 1, and we've successfully changed all the M's and B's to those values. And then finally, we want to check that all of our columns are numerical, so we can use .info, and this shows us that they are all numerical.